I'm Hannah Kim from Georgia Tech, and today I'll talk about discovering common and discriminative topics using joint non-negative matrix factorization. This is the joint work with Dr. Choo from Korea University, Dr. Kim from Netflix, Dr. Reddy from Wayne State University, and finally Dr. Park, who is my advisor. So I will start with motivation. So understanding large-scale document collection is an important task, and to do that, in many real-world applications, we sometimes need to compare and contrast different document sets. For instance, we may want to analyze those document sets with respect to additional information that comes with them, like author information such as author's gender, age, or network information like citation, or even publishing information like year or publisher. So, for instance, let's say we have documents written by male authors and documents written by female authors. We want to find out what are the common topics among those two items, and what are the exclusive or distinct topics written by those two groups of authors. And we may want to compare and contrast old document sets and new document sets. However, the problem here is that standard topic modeling cannot fully satisfy the goal of comparing and contrasting these two document sets because independently running standard algorithms on both datasets does not clearly reveal their common and discriminative topics. So I'll give you an example. So here now I have two groups of documents, which are research papers published in data mining area. So the first group is published from 2000 to 2005, and the second group is published in 2006 to 2008. So I ran the topic modeling separately on those two document sets, and I picked a seemingly common set of topics. So the left ones are from the earlier years, and the right ones are from the later years. You can see that these seems common, but these are not really common. So this is the results from our joint topic modeling. So now we clearly have the common topics, which are the green ones, and discriminative topics, which are the red and blue ones. So the common ones are outlier detection and clustering, which is consistently studied over the whole period of time. And the red ones mean that large-scale graph modeling and social network analysis have been recently emerging as a research subject. And blue ones, the associative rule mining or frequent pattern mining, these are receiving less attention in the later years. So before I go into our underlying technique, I'll briefly go over how non-negative matrix factorization works in the topic modeling context. So basically what NMF does is that given a matrix X, it represents X as a product of two matrices, say W and H, with less dimensions. So in the topic modeling context, we first represent a document collection as a term by document matrix here. So for instance, the first document in this document collection is represented as these vectors. So if you use a bag of words model, the first document has the word apple twice and the word fruit 3 times, something like that. And after we apply NMF on these term by document matrix, we got two matrices, which is term by topic matrix and topic by document matrix. So now each topic is represented as a non-negative vector or non-negative distribution of words, where each of these values means the word's rank or representativeness in this topic. And each document is now represented as a linear combination of topic vectors. So for instance, now this first document is represented as the sum of first topic and 2 of the second topic. So then how we actually calculate the W and H? We first initialize W and H and update them according to the objective function, which is basically minimizing the differences between X and WH. So now here is our joint NMF-based model. So now that we have 2 sets of input document sets, so the goal here is that given those 2 data sets, we want to find what are the common topics, which is represented as the 2 blocks in blue box, and what are the discriminative topics, which is represented in these red boxes from each data set. So now we have 2 X's, and we want to find W1, W2, H1, H2, where those common factors are as close as possible, and those 2 discriminative topics are as different as possible. So this is our new optimization function. So we now have 2 additional functions, each for commonality and 1 for distinctiveness. So the first first additional term makes common topics in each of the data set as similar as possible, and the second additional term makes the distinct topics from each data set as different as possible. And to actually calculate W and H, we use a block coordinate descent framework, meaning that when you try to solve for all the elements in W1, W2, H1, and H2, we separate them as blocks, and we solve for each block at a time. So in this case, we set a block as a column vector. So when we solve for one column vector of either W or H, we fix the other column vectors and solve for only that vector, and iteratively update them as we go. This one was called batch processing approach, and we propose another approach which is called pseudo-deflation approach. So the motivation of these approaches is that in practice, when people try to understand topics, they usually check only a small number of the most representative and thus the most meaningful keywords. And our pseudo-deflation approach considers only these top keywords in each topic. But considering only these top considering only these top keywords presents a challenge, which is the objective function could change over every iteration. So to solve this issue, our pseudo-deflation approach discovers discriminative topics one by one per each stage. So in a similar manner to a ranked deflation procedure. I'll skip the detail, but if you're interested, please see our paper. And to evaluate our methods, we performed clustering. And our assumption here is that since we are jointly performing clustering on multiple document sets, and we are allowing both common aspects and discriminative aspects, so our method would show better clustering performance. So these are the compared methods. We compared the standard NMF and multi-view NMF, and also regularized shared subspace NMF. And we used these 4 well-known clustering measures. And these are the results. The red box ones are indicate the higher the better, and the blue box indicates the lower the better. You can see that this highlighted 2 approaches, meaning our batch processing and pseudo-deflation approaches, show mostly better results in 3 data sets and 4 measures. And I'll move on to our 2 case studies. So the first case study is about research papers in two major visualization conferences, namely VEST and InfoVis. For those of you who are not familiar with visualization community, VEST is short for Visual Analytics, Science and Technology, and InfoVis is short for Information Visualization. Also, VEST conference is mostly about visualization combined with data mining techniques and human interactions, while the InfoVis conference is more about generating views to present information. So these two green topics are the common topics that are researched by both conferences. So the first one is interactive visual techniques, and the second one is about user interface systems, which is quite common visualization research topics. And VEST exclusive topics are the blue ones. So the first one is high dimensional data visualization using dimension reduction or clustering. And the second one is visual analytics helping decision-making processes. And InfoVis exclusive topics include color weaving or color blending techniques or graph layout algorithms. So this clearly shows the commonness and the differentness between those two conferences. And the second case study is about loan description data in microfinance. So the data source here is from kiva.org, which is a non-profit crowdfunding website where people in developing countries post their loan requests like this. So they explain why they need the loan and what they're going to use it for. And lenders anywhere in the world can make a loan by just clicking here. So they can either do that individually or as a part of a lending team. So these lending behaviors are purely based on altruism, meaning that they don't get any financial incentives like interest. So by analyzing these loan description data, our method can help characterizing and promoting the lending activities. So now the two document sets are loan descriptions data. The first group is loans funded by the lending team Etsy.com, and the second group is loans funded by Team Guys Holding Fish. So the first team is the users of Etsy.com, which is a website where people make handcrafted items like jewelry or clothing and sell them. And the second team is obviously guys who like to fish. So the green ones are the common loans that are funded by both groups. So these are basically very common theme of loans in the kiva.org. So they want to buy some supplies to sell, and they also want some farming supplies and seeds. And interestingly, the loans distinctively funded by Etsy.com users include fabric, thread, and clothes. So these are very much aligned with their interests. And also, the loans funded by Team Guys Holding Fish include like fishing nets and shrimp boat and repairs. So these are basically fishing-related loans. So this is the case of homophily, meaning that people tend to fund loans similar to what they like. And the next example is loans funded by teams Thailand and team Greece. So basically, these two teams are consist of people from each country. So again, the common topics are pretty common themed loans like buying groceries and expanding businesses. But the Thailand exclusive topics include vegetables, fruits, and like sugar, rice, beans, the agriculture themed topics. And Greece exclusive topics include construction materials like cement or sand and home improvement projects like this one. So according to World Bank research, 40% of Thai workers are in agriculture, whereas only 13% are in agriculture in Greece. And also construction and industrial manufacturing are like two of the most leading industries in Greece. So again, this is another case of homophily. And third example is about lender occupation. So the previous two examples, we saw the loans funded by lending teams. Now we are focusing on the individuals. So these three are the distinct topics of loans funded by a specific set of lenders. So the first one is the loans exclusively funded by lenders who have jobs relating arts. So you can see that clothing and shoes and construction materials. So these are art-related topics. And the second one is the loan funded by drivers. So you can see that these are topic of car-related ones, saying car repair and buying spare parts, something like that. And the third one is the loans funded by teachers. So you can see that these are education-related topics. So they're gonna pay university tuition and fees for school. So again, people like to fund loans that are related to their jobs. So another case of homophily. So in conclusion, we presented a joint NMF-based topic modeling that identifies both common and discriminative topics. And we plan to, in the future, build a real-time visual analytics system for this, so users can interactively find common or discriminative topics. Thank you.
We have time for one question or two. Any questions? Yeah.
So you showed your objective function, but you didn't say how you solved it.
Oh, okay, I see.
Are you using ALS or something?
Oh, actually, we're using a
Can you repeat the question?
Okay, so the question was that I didn't show how to solve my objective function. So just let me go to the. So we use a block coordinate descent framework, meaning we fix one vector and solve for the other.
Any more questions? Yeah.
Yeah, the way you present the objective function, it seems like you take the hypothesis that you will always have common topics and discriminative topics. So if I run the system on the same set of 2 times on the same data, you will present common topics, and you will also present discriminative topics. So my question is, how do you think it's possible to quantify to which extent I can trust that the topics are very discriminative, and to which extent I can trust they are not so discriminative?
So can you repeat the question? So I'll just repeat the question quickly. So his question was, you have to decide the size of the common and discriminative. So how do you know this size? Sometimes 1 is 0, sometimes, right? So his size, like maybe the 2 corpus are very similar. There is no discriminative topic. So how it can discover that automatically?
So actually, choosing the number of common or discriminative topics is a very difficult problem, which is similar to setting K in K-means problem. So one way is we can iteratively try different numbers of common topics and different discriminative topics to see if it makes sense.
So you can do cross-validation. Okay. Okay, so let's thank the speaker again.
Okay.